So yeah, we're gonna start the stream, I guess. Um, yeah. Uh, today's agenda pretty much is to like finish our little like reactive system. You know what I mean? Just finish that up and just get over with it. We'll split vertically. Buffer. Let's just open our tests and just put horizontally and just uh, buffer. All right. That H. Okay. Yesterday we managed to like make it work until at least this test where we like compute we like have an input cell and like we have a compute cell and like those are linked and we pass like a function pointer and we just get like the value in like real time. You know what I mean? Not real time, that's not the proper word. I mean like you know what I mean. Anyways, that's pretty much what we're doing. I think this test might work. This one where like the ordering matters. Oh. Okay. This requires less to like finish up like the CompuCell 2 stuff, you know. So that's first let's like take this. It's just like add references to like the first and second cell because that is like essentially what we're gonna be operating on. Cell second and our function pointer. Gonna call it func. Well, that's pretty much it. But also need to like add like the function that is needed. Create a compute cell. So we just take that here. You just take you just copy most of what is here. No, let's just copy like this first part at least. And I have to like assert that everything here is just I have to assert that our count does not exceed our like our defined count over here, because if that happens we're gonna like we're gonna be writing into memory that's not ours, so that's gonna be causing problems. So I reckon that instead of having to deal with that, we just asserted it. I mean, I'm pretty sure that they do not do that here in these tests, but maybe later. So oh, we need like an out. Just set the type of our like tagged union to like a compute cell, and that's got to be compute 2 because it operates on two cells, and we just since it's a compute 2 cell, we just take the first, we just assign that to the first, and second, just taking the second cell, and we also put in our lovely little I don't know function pointer. We get that to no, I'm not returning the func, I'm returning my cell. So we do that, and back here we take in this, and we just since it's a compute 2 cell, we just make a func and just take compute to first and get cell value. See, we're gonna have to format that a little better, but it's not too bad, I guess. Oh, it's not what I was supposed to be doing. This is why you have to format from the beginning, you know what I mean? Let's just do it like this and like this. And we just take that one in. Oh, I guess when we're in C, that makes sense. We just do that. We take our first value, taking our second value, and that is going to be computed. This is obviously not going to be efficient because it's like a recursive function, but I just want to solve it at the moment. Maybe we're going to look into like memoization or whatever, but for now, I feel like we're pretty good. We're doing good. So let's just remove ignore from the test and just make it. Okay, we pass. So when dependencies are changed, so it like sets an input value and like it changes the input value. So it expects the actual the compute cells value to change as well, because that's essentially what would happen in like Excel as well. Because if you like modify the like number that you're like referencing from another cell, you have to see that value reflected back where you're at. So I think it will work fine. Yeah, it does. Okay, next. Compute cell. This should work. This should work just fine, because this is essentially doing like building out a tree structure where like this is kind of the root node, and these are like leaves, but not really a tree structure. I guess more of like a graph. But we take the input and we just times 2 it, and we times 30 it, and we just add those values up, and it should just work fine because of the way that we implemented it. We gotta pass that test. Okay, now is the most complicated part of this whole thing, because we're gonna have to be dealing with like callbacks, and I'm gonna have to figure out how to like make those work. I figured this out before because I was doing this exercise and I didn't like the code that I wrote, and it wasn't working for like one of the tests that I'm kind of dreading. We're gonna get to it, but I had like somewhat of a solution, so I have to like somewhat rethink it. Let's just look at the tests and try to like figure out what it's expecting from us. Okay, like fire callbacks, we just set a callback on like the output, and just it expects that callback to be fired immediately. You know what I mean? So that one is simple. You just like add like a callback, like an array of callbacks, and you just execute all of those. That's pretty much what I was planning to do. But when you get to the other tests, they not only just fire the callbacks, they kind of want, for example, when like input changes, it wants the output value to fire its own callback. That's what I got from it, at least. So like, for example, I think it's here, you add a callback to like the compute cell, and you have a callback to like the this other compute cell, the -1 and the +1 cells. And essentially, when you like change the value, it expects them to like the callback. It wants the callbacks to like propagate upwards. You know what I mean? And I do not know how I should be doing that. What I'm thinking is essentially like have like an array of callbacks in each cell, and when some cell like is setting like a callback, it goes down like the tree structure, and it sets that same callback everywhere. And that callback will definitely be called, but yeah, like it should be called all the time. That's what I'm expecting it to do. I don't know if it's like an invalid assumption to make, but we're gonna try to figure it out. There's something interesting that I saw here. Essentially, have like a call, like the callback is being made. Wait, I'm not sure I understand what this is trying to do. So just, I think that behavior is gonna be revealed in a little bit. So for now, let's just have like an array of callbacks here. Where is like my callback function pointer? Just take that here. Wait, why did I jump? This is some annoying NeoVim bug or whatever. I don't know if it's like a configuration issue or whatever, but it's like this annoying thing that I'm having to deal with. But anyways, let's just I think 32 is enough for now. And not compute callback. Callbacks, since it's gonna be an array, we just callback count. And that's gonna be it. So we're gonna be taking this add callback function is needed. So this is kind of interesting. Maybe we could like register callbacks. Wait, let's just try to solve this first test case. Okay, so let's go down here. So you need like a callback ID, and the callback ID is basically just an alias to integers. What I'm planning to do is just take callback. Oh yeah, just the data that it just wants to like put inside that callback, and just let's call it callback, I guess. I don't like this naming. Let's go as CB. Okay, CB data. So we want to like assign a callback ID. We also, when we remove that callback, we want to use that callback ID, and we just remove it. That's what it requires us to do. So what I'm thinking is, for now, let's just take our cell, just take our callback, We need a callback count. I really don't like this, but what else can you do, I guess? But we take this and we just make that callback. We take wait, x so we take, oh yeah, in this case I guess we have to set that callback to CB. Okay, what do we need? The callback should be called with the same void pointer given. So essentially we have to like make our own struct, I guess. Oh, I guess I'm gonna do that. But call it funk, I guess. And that would be a pointer to callback data. My naming is pretty bad. Let's just take that here. So yeah. Oh, we just need like set the func to like I call my function func. Data. Okay, I guess. Then we return cells callback count. I don't really like using the postfix operator, so I'll just say out. this one. It's kind of a little bit bothersome, I guess. Okay, a little better. So this ought to work. Oh wait, oh, when we want to fire our callbacks when we like set a value. So what I want to do is now this is the problem that we're going to be facing, because our callback is like registered on like the compute function, the compute cell, and we wanted to like detect changes to we wanted to detect changes to the cell that it's referencing. We want that to happen. So what is the best way around that? Let me think. We can like have like a reference to like a parent, every cell like refers to like their parent cell, and no, that's not what we need. We need like every cell to keep count of it like it's children, I guess, so that it can like trigger their callbacks, I guess. I do not like that solution though. Let's just do this. That's pretty much what we expected to happen, I guess. Because it's not being called at all. So the best solution here is I really can't think of anything. Okay, I have to do something. How do we solve this? I guess we can like register, like every parent like registers their own callback that kind of gets called when they're like a child, You can like make this add callback thingy here recursive. So we can try to do that, I guess. But is that like a good idea? I'm not really sure. I think that's like the best idea though. I feel like I can use like this void pointer to like pass in my own like struct that I expect Oh no. I cannot really call like the remove callback thing in an easy way if I do that. So maybe the solution to that is I guess I have a reference to my reactor. I can make it trigger something, make it like walk down the graph or whatever every time something changes. I guess that's not really a viable solution as well. It's really confusing. I had solved this before, but I don't like. I don't. First, I don't even remember. It's been a while. I wanted to finish it, and I didn't get to it because of my job. So, um, I have to like find a way to. I guess every cell has to like keep track of its like children. I feel like that's the only way to really do it in a way that kind of works, you know. So um let's try to like write notes on this. I want callback to be triggered when there's like a change to my input cell. The only way I can think of doing that is having like an array of cells here that we kind of keep. Not cells, but references to cells, so like a double pointer of sorts. We keep track of that. Then we would also have to like maintain. I have to think about allocating this, which I'm not really fond of doing. Let's try to like. So it essentially expects like a full blown like double doubly linked, not doubly linked. Yeah, I guess like a graph of sorts where like changes are like tracked upwards. So if that is the case, um, okay, let's try to think of a way to like make this into like, because these are the possible edges. So this is kind of solved, but the parent, we have to like keep track of the parent. And the parent will be, wait, a cell like refers to another cell. And it refers to another cell. So when something changes here, we want it to be reflected up here. So my switch trick cannot be working like that, I guess. So when we set values, we need like a double-edged type of link, you know, a two-way link. So I feel like yeah, I don't really see another way out of it. So just have like a parent, I guess. And when we're trying to set we try to like set a cell. No, that's not what I mean. Yeah. Also want like our input to have a parent, and the output would be like the parent. I guess. Maybe we have to like yeah, we have to copy this one as well first. So when they have changes, they can trigger callbacks from their parents. So I think that should work. Okay. So we're setting a cell. We do this. And we also yeah, we need like a recursive function. Void trigger callbacks. We need a reference to like the cell. Want a loop through all the callbacks that cell has. So int I 0, I less than ref callback count. We want to just increment our I. So since we're setting nulls, since we're using calloc, I can pretty much be sure that we can just stop doing this when we kind of reach when the parent is null. So we're just gonna call the callback. pass. Oh, yeah. And you pass in the data that it was supplying us. Wait, okay. Where's our callback function? Oh, yeah. Pass in back I as the data, and we, I guess, get self value. This is not really efficient, but and if us wait, because I know that this could be null if it's not set. If I don't know if it's like a good solution at all, but I'm just gonna try it. These Golang habits making me waste my time. I mean, parent. When the value is set,
Miki, dapat falan?
okay, so I had to do something super embarrassing, but whatever. I don't care. Anyways, let's get back. Let's switch our scene here, and let's just put this is that the ref is not equal to like this is terrible code, man. I hate this. But, maybe I'll get to refactor at some point, but parent. What? Wait. Oh. I think it's because it's like self-referencing. Kinda needs like these annoying parts of C that we have to deal with, I guess. This is interesting. Because it should get called. It should be getting called. Okay. Let's try to like print log it, I guess. Good. Let's just okay, that means that we're having a null thing here. That's crazy. So I thought setting our func here. It's not equal to null. Oh, what are we missing? Okay. guess we have to like cast it. Oh man, I hate having to do this. Ugh. Should be -1 and 0. What? Oh, I think I realize what I'm doing here. Has to be I. Yeah, we passed the test. This one is the one that I'm dreading. Oh, excellent. Yeah. Okay, well, we're doing that in the background. I think we passed the test, so let's try to pass the next test, I guess. Only on change. So int temp and if our like if you've not changed, we don't want to trigger it, so only trigger it when we're changing. So terminal value, trigger the callbacks. Okay, we're having memory leaks. We're gonna worry about that later. Okay. should be working like that. What? Why is it not working the way I'm expecting it to? Okay, let's fix the memory leak issue first. Wait, Peanut, freeing the guy. I do not know why this is being triggered. Okay, we expect that it to not be called if you're like setting it to the same exact value. What? Oh. Okay, I think I know what it is. The test requires us to not do this check here, but instead first things first, let's try to should not break our test. Oh, yeah. We want to store like temporary data. Oh. Now we're in a bit of a bind because okay, problem we're having is when we set a value, we want the new value only. We want a new value only to trigger the callback. So, like, we wanted to trigger an actual change, which means that we have to somehow find a way to pass back the old data back in, you know? And I'm not sure if there's really a way to do that. Okay, let me think. So we have to kind of like recurse here in like our set value thingy, you know? We have to do that recursive thing here, not inside like another function, because there's no other way for us to like have access to it. Or we could like, you know, um, have like a last value thingy going on. So maybe like or like compute cells should not be just doing this. They have to like keep an actual like current value thing. I guess that is much more optimal if you think about it. So maybe we have to go with that. I guess we got it. So let's just do this. Let's go up here. Let's do the same. And when we get our value, we just want to like because we already kind of cache it, so I don't think see need to like, you know, yeah, I don't see the need to do something like this, just to do like a recursive thingy. But when we set a value, we have to do that recursive thingy anyway, so we're just kind of shifting it. But anyways, we create a compute cell. We also want to set our initial values. Good. Compute one value to the value of our func with the input. Okay, this gets kind of complicated. So we're gonna essentially have to move this up here. In this case, just remove the value. Just get the value. Stop having values over here. Essentially, this function just becomes like a very simple return. this and just move all of this. And but when we set a cell, yeah, we have to still assert. We have to find a way to like recurse upwards. And not just call the callbacks, we have to also set the values. Like our initial values. So value trigger callbacks. So what we're gonna do is we're gonna have to like recursively call everything. Okay, let's just do that here. First we have to stop first. I want to do a bit of like an optimization thingy here. If temp is different from the new value, we trigger, we call our function. We're gonna call trigger for now because it's not just triggering callbacks. Yeah, we wanted to like trigger the parent. So if our parent is not null, what you want to do is to oh hell no. I'm not really seeing something. I think I'm good for today. I'm just not feeling that well as well, so I'm just gonna try to find like better solutions, I guess. But this is not it. This is not the best way to go about it, I guess. So yeah, I'm just gonna end the stream here for now. Um, so yeah, I'm gonna try to like look up some stuff on this. I'm just way too fucking tired to resolve this at the moment. Having issues with that. So yeah, adios, I guess.